So here's a little example of being able to differentiate distance and displacement. A car is parked at a parking garage that's located at the origin of a coordinate plane. The drive home is 6.5 kilometers as the crow flies in a direction 30 degrees below the y-axis. The average speed of the car is 10 meters per second. The driver takes 20 minutes to drive home. What extra distance did he travel as opposed to going as the crow flies? So I recommend you try this yourself, and when you're ready you can come back to this video. You will need some vector knowledge before this, however, so just make sure you know your vectors very well. So here's the solution. We're first going to start off with this diagram. So this, we use the letter S for displacement. So he's displaced 6,500 meters from the origin, 30 degrees below the y-axis, and he's ended up somewhere here. Now, average speed he traveled is 10 meters per second. The time converting between minutes and seconds should be fairly straightforward. You get 1200 seconds. So distance is speed by time. So that's a key thing. All the scalar quantities have to be next to each other. Well, if you want to end up with a scalar quantity, you have to have two scalar quantities here as well being multiplied by each other. So you have 10 by the 1200 seconds. So that gets you with 12,000 meters. So he had to actually travel 5,500 extra meters to get to his destination. This might have looked like maybe taking a ring road. Or he could have had to do a diversion along this track, so maybe he had to go out here for something and then back in. So there's a multitude of different reasons that he could have traveled extra. But in this particular case, he traveled 5,500 extra meters.